Welcome back. We now begin session 3 on global data standards landscape perspective. This session will provide valuable insights into the evolving landscape of data standards worldwide, highlighting key developments, challenges, and opportunities. Let's get started. To begin session 3, we now invite Mr. Vikas Chaurasia to deliver his keynote. Vikas Chaurasia is a scientist at the Ministry of Electronics and Information Technology, Government of India. Uh, Welcome, Mr. Vikas. The floor is yours.
Hello, good afternoon. I am Vikas. I am a scientist with Ministry of Electronics and IT. And I am not the scientist which you probably are. I am more into the policy space. And for last 7 years, I am pursuing this one particular thing, which is digital personal data protection. And I've been in this journey. So I would I would say that my challenge here is in two folds. So one is like I've been given some or 10 minutes. So 10 minutes is very difficult for somebody to take you through a journey of a topic, which has years of evolution. And second is that it is post-lunch. So both are increasing the complexity. And with that increased complexity, I would like to begin with one specific thing, which probably when I was thinking, when I have to speak here, and it is IoT and M2M. So I thought that what could be my pitch and how could I make things really relatable to the audience which I'm going to talk to. So I found a very interesting thing that that kind of relates to this. So the Digital Personal Data Protection Act, which was passed by the Parliament in 2023, and we made rules. We have made rules, the legislative part of it, and we have made a draft of it, which is there in public for comments. So those comments we are inviting, and post that this act will come into force for the country. So very interestingly, that personal data, the definition of the personal data states that personal data means any data about individual who is identifiable by or in relation to. So anything which helps somebody being personally identified is in the scope of this Personal Data Protection Act. So as IoT standalone probably is just a sensor, but when it gets related to a person, then this comes into place because a lot of data manipulation we are seeing in the current world. I'll just try to uh, take you to a quick 6-7 slides, and these are all broad level considering the time available. So what we have done is this Digital Personal Data Protection Act 2023 marks a transformative step in India's journey towards safeguarding personal data. So anything and everything relating to personal data comes in the ambit of this act. We have also seen a lot of international legislation around it. GDPR is there, a lot of American legislations are there. And our concept and philosophy have been adapted and appreciated by the world is clearly visible because the terms which we use. So for all of you, I just want to bring two very quick comparisons. So General Data Protection Regulation, which is a European legislation, calls a person whose personal data uh, is termed as data subject, and somebody who owns that data, a company which is playing with that data, which is trying to make economical sense of that data, is called data controller. What we have done is we have changed the spirit of the whole relationship between our personal data and the person who's using it, the company which is utilizing it. What we call it as data subject is called data principal in our case in India. It is called data principal. Somebody whose that data is about. So whose data it is principal. And the other body, the company which is collecting that data is called data fiduciary. So fiduciary is something where fiduciary is a term which is taken with a doctor, with a lawyer, where there is a trust relationship. So what we have thought of in India is that there should be a trust relationship between somebody who's collecting my personal data, and then he should behave that responsibly because a lot of trust is being transferred to that company. It's not a controller who's managing my data, me as a subject, but it is I am the data principal and my data is being handed over to a data fiduciary. So those are two interesting terms which world has appreciated now. Different laws, draft laws which come usually take this term, and that's how we have redefined the whole dynamics of digital personal data protection. Also, just to create, also one more challenge was there that the growing AI, the growing IoT, M2M, or whatever we say, the growing technology poses a lot of challenge on personal data, and there is a very fine balance required between promoting innovation and remaining conservative in terms of remaining keeping the protection there. So that was a very big call, and India is known to be a very innovation friendly and innovation pro country, and we are leading in so many domains that way. So we were having a very difficult task. So our act kind of attempts that. Very interestingly, four core pillars for the act, which says that consent as empowerment. So any data being collected, there should be a consent. Now we have said that consent should be given, a choice should be given in all languages in 8th schedule. So any Indian language, that consent should be made available in that language. So that it is understandable by somebody. It's no more a two-pager legal contract which we all sign before entering into any such agreement using an app, getting to a platform. So that we have tried to redefine. Also, we have said obligations on data fiduciary. So as I told you, what is data fiduciary? Somebody who's collecting my personal data. So that company is required to be obligated to keep reasonable security safeguards. So the company should ensure that that data is protected well. They are also required to use technical methods or controls like encryption, access control, and a lot of things are evolving. Our law is technology neutral, and we have never said which specific technology, but we have given a very principle based approach. We say that what has to be achieved, what technology needs to be deployed, that data fiduciary takes a call. So that has been the approach. And also we say that transparency in data handling practices. So anything when somebody or when an app company takes my phone's battery percentage and tries to do a competitive pricing around a cab service, it's not transparent because they are trying to exploit that bit. Somebody knows that okay, this fellow has to leave for airport and has 5% of the battery. At that point in time, I would take a decision of taking a cab at a higher price. So that is something which is not correct. So we try to address those principally by obligating the data fiduciary to remain transparent and purpose limited. So if they have collected a personal data for one purpose which they have taken consent from me, they should stick to that and they should not extend the scope of that consent or keep processing beyond my expectations. So that is the structure. And very interestingly, data principal rights are there granted to the citizen whose data is being collected by the data fiduciaries. So very interestingly, right to access. So first I should be knowing that a company possesses the data of me. Then to correct it, a lot of automated decision making happens and which are impacting lives. So we wanted that that personal data which causes, suppose a bank decides through an AI algorithm my eligibility to take a loan. That's a decision which is going to impact my life. And if that personal data is incorrect, suppose my bank AI takes a decision based on the SMSs which I am getting, and by mistake somebody else's salary is being mapped to my mobile number, like somebody's bank account is mapped to my mobile number and suddenly somebody, so that is all wrong picture being drawn by that AI around me. So that's where correction is also one right. Erasure is one right. So if I don't want to continue with that particular business relationship, I can request for erasure of my personal data. And flexibility is given to organizations to response time. Okay, that detail we won't go to. And a very interesting, at the end, if you could see, that is a right to nominate a representative to manage digital rights, data rights, in case of death and incapacity. So very interesting fact is that on Facebook, 10 years from now, there will be more dead people than living people. So it's a fact that a fellow dies, that Facebook or that Gmail or that account just exists. So it's no end to it. So we have come with a very novel, first in the world kind of structure, legal structure, where there's a right to nominate. So I nominate somebody who will be taking decisions on my behalf in terms of my digital personal data in case of my death or in case of my incapacity. If I'm not able to take a decision, medically such condition is there, then that right could be exercised. So that's something very new and novel. And also there is a board, a regulatory mechanism which can resolve the complaints if they arise. So there is a digital personal data protection, digital personal data protection board, which resolves to the complaints. Uh, by this, we wanted to promote accountability. So first of all, somebody who's collecting data is accountable. We wanted to bring that on the table. We wanted to ensure a conducive environment for the innovation to go. We didn't want to grow. We didn't wanted that to be stopped. So a lot of sandboxing kind of approaches are coming when personal data is involved. And also, uh, we wanted to offer balance data protection as a competitive advantage in the world. So if a company says that our practices are good, they this is the trust factor which is nowadays required for a company to establish to get business. So that is three core parameters. When this act comes in play, it says that a lot of implications will be there on industry because it is a cross sectoral law. It's going to impact each and every organization in the country, be academia, be IT, be banking, any damn thing, wherever there is personal data. And now coming here, I'm thinking, yes, to our scope, IoT also falls in because when IoT get associated to account, which is this, so say suppose a smart meter IoT device, which is monitoring my electricity consumption uh, when I am at home, when I'm not at home on an yearly basis, trying to optimize my electricity consumption, probably giving me a report in IoT. So that IoT also is creating data which is now being associated to me becomes personal and hence comes in the ambit of this act. So a lot of practices needs to be adapted by the industry. Industry needs to handle the re-engineer the process how they handle data. It's very interesting. I now I'm with a technical fraternity here, so I can pose one example when I was trying to advocate for this act at various levels. In government, taking out a legislation is a very big task. So there are n number of stakeholders, and you present to different people in different formats. So then somebody says that summarize me in one line what will be the impact of DPDP, what all needs to be done. When I said that when we used to program, we used to say field. Okay, field is name, maybe address, something like that. So in a database, there are fields. And then till now, what we were doing uh, attributes when a SQL query runs, we say that extract names from the name field in the database. But now it's metadata about every particular field. So I may choose to share my name, you may choose not to share. So that SQL query has to now look for those details. So every data field, so we are trying to like metamorphose the whole IT system because suppose you are storing 600 one single column database with 600 entries. Earlier was 600 entries. Now 600 entries multiplied by 2 because every entry's attribute has to be same. So that because that's personal data, that kind of process re-engineering is needed. We also say that transparent data security and data rights management. So that also has to be thought of that every time these kind of processes like nominate has to be enabled by an organization. Right to nominate has to be taken care by every organization. So and also we say that it helps in the whole digital India landscape by bringing DPDP. We are now at par with all uh, global majors where they have a privacy law, and now we also have a very detailed privacy law. So that exactly is the thing. Some final thoughts are like we are just, as I said, that we are presently having public consultations on the draft rules. which anyone can contribute to. There is some MyGov portal where you can go and rule-wise give us some comments. So we are just at the cusp of this whole new era of data protection, redefining the processes. We realize that there is a lot of potential in collaboration and doing things because it is so industry um, horizontal applicable. It's not an industry vertical law. So a lot of things which we are doing are there. Citizens must stay informed, vigilant, and together we can create a digital, well-footed, trust-based system. We are, as I told you, we are presently holding consultations on draft rules, which anybody can contribute to. Given the time, I could not really go in the details on the act, but I wanted to bring some sensitization and structure around things happening when you're thinking of IoT, when you're thinking of machine to machine communication. You have to think that if that machine is transmitting, if that API handshake is sharing the personal data, yes, then DPDP comes in play, and the user can sometime come and say to you that I want to delete. Now say I want to delete, then your system was not designed to even think of deletion at any point in time, because you thought that over a year you will give a fantastic energy saving guideline to a user, but in between the user says I want to delete, I want to nominate somebody. All that has to come as processes in any and every system being designed. And to end at point three, I say that M2M or IoT, wherever there is personal data, DPDP Act comes in play. That's my thing, and that's the thought I would probably leave you in quick 10 minutes. I hope I did a little justice to the time given to me. Thank you so much.
Thank you, Mr. Vikas Chaurasia. Now I invite Jason Song, 1M2M TP Vice Chair, to deliver his keynote. Jason Song is a professor at Sejong University, leading the software engineering and security lab in the computer and information security department. Mr. Jasam will be joining the conference remotely.
Yeah. Can I share my screen?
Yes, you can share.
Okay. Because I don't have an access to share my screen.
He's not having.
Okay. Wait a second. Oh, it seems like I need to have.
Yeah, you can now try sharing your screen.
Yeah, but it seems. Wait a second. It seems like there is also issue in my computer to have access. So if you're okay, then would you please open my slide there? Then I can present it. Otherwise, I have to turn off my computer and then join again. But it takes time. So please share my slide. No, that's Singmyeong's one. Yep, that's the. Okay, so can you make it bigger?
Make it full screen.
Okay, if that is
No, no, from there, na, bottom you click the plus sign. On the right, push it button. Yeah.
Okay, whatever. Okay, you can download it and then open it. Yeah. Okay, so thank you. My name is Jae-sung Song, as introduced. I'm a 1M2M TP Vice Chair and also from Sejong University. Today, I would like to share my thought about 1M2M standard and then also where 1M2M standard need to go in the future. So could you go to the next slide? So today you heard of various, thought from different standard bodies, and then you remember that most of them have been talking about data, right? Because data is now very important for various, emerging technologies. And then 1M2M, which is the data platform for IoT, can be the center of those different emerging technologies, providing quality of data. So I would like to highlight those aspects in my talk. Please go to the next slide. Yeah.
Close it.
Yeah. So
Previous.
now, so now, IoT is becoming as an infrastructure. Previously, in 1M2M, we focus on standardizing a common service layer platform, and then now it becomes the infrastructure of various emerging technologies. For example, IoT now can make AI smarter, and then IoT as metaverse backbone, and then data trust using blockchain, and then data offloading edge IoT, and so on. So IoT service layer platform is now used in various emerging technologies to make them smarter or make them provide better performance and so on. Please go to the next slide. And then as you can see, the data from real world collected or gathered in IoT platform, and then it is distributed to or used by various emerging technologies. And then not just usage of those data, but also there exist many critical regulations that platforms use data has to follow, like a GDPR, and then in South Korea is PIPA, and then there are several, standard bodies. They are also standardizing regulations related to data and so on. So not just usage of data, but also IoT platform as infrastructure of various emerging technologies need to consider regulations from different countries, right? I understand that India also has those regulations. Then what does that means is IoT platform need to compliant with those different regulations, right? Sometimes, the regulation in one country may be conflict with the other countries, but standard as a standard in 1M2M, we need to resolve those kind of issues as a data platform. Please go to the next slide. And then, if you remember when AI was first, started to getting highlight, all the people, all the researchers and companies and so on, they said AI can make IoT smarter, right? That is true. So many AI companies, AI services, and so on use IoT services to make them smarter. But what happened AI? How AI can be smarter or how AI can provide more accurate, decisions and so on. It is all about data, right? Now we are talking about the LLM and then SSLLM and various AI models and so on. But The data is the core. Without data, AI model cannot be smarter, right? So we have already seen various use cases and then examples in the world that AI service was introduced, but those AI services provided very biased, news or services and so on. The reason of those things are the data, right? If data is not correct, if data is not accurate, if data is not quality, assured, then AI model cannot be, used by us. So we have to focus on IoT data can make AI smarter. Please go to the next slide. So there is like a complementary, concept. AI can make IoT smarter, and then IoT can make AI smarter. So with those complementary concept, the AI and then IoT can make world, better, right? So probably, definitely, AI developers and service and folks, they will focus on make IoT smarter. But from our perspective, we have to make our standard better to provide quality of AI training data and those data, right? Go to the next slide. So based on this concept in 1M2M in 2023, we studied a new work item, system enhancements to support AI capabilities to provide required capability for AI ML, which means that we analyzed how AI model is developed from start to the end, right? There exists like a 7 steps or something like that. And then all those steps are engaged with data, right? Data collections and then pre-filtering of those data, and then make those training data bigger, and then make a smarter and so on, and then use those training data to train the models and then evaluate the models and so on. So all those AI life cycles are related to data. Then, from 1M10 perspective, which is implementable standard, we need to provide the data that require AI model to be generated, right? In every single step. So we analyze those requirements and then try to identify what kind of features, what kind of requirements are needed to support those data management for AI ML model services. Please go to the next slide. So based on that, we identified several common service functions for AI. For example, managing training data for AI, and then managing AI model. Even model itself is a data from our perspective, right? And then AI data labeling, and then AI data augmentations, and some sensor data calibration using AI and so on. So those are several capabilities that we identified through this new work item, AI enablement to 1M10. And then if those features are integrated in 1M2M, which means that 1M2M can be a platform for AI, which means AI developer can store training data in 1M2M and then try to find out best training data to train their model. And then when they train their model, those model can be stored as a data in 1M10 platform, and then different service of AI companies, they retrieve those model and then they can use it. And then when those models are trained again with the better data, and then those model can be updated and then stored and they can be used by other AI services. So that's the vision of this work item. Go to the next slide. And this is just one example of identified capability in 1M2M, the data augmentation of AI. So in the supervised learning, we need like a set of images to training AI model to identify whether this is cat or this is dog, right? But maybe we have just like 100 photos of cat, right? But that is not enough to training the model. In that case, what happens? Typical approach in that case is to data augmentation. So they try to, rotate the figures, and then they try to change the brightness, and then they try to, apply different filters and so on. So even they have, the AI developer had like 100 images of cat. They can make it bigger, like 1,000 or 3,000, even 10,000, using those data augmentation, right? So they can make training data bigger based on their need. Then 1M10 platform can support those kind of features, right? So we have a set of, AI training data in our resource model, and then AI developer use API to augment those training data. Then they can have bigger model, bigger data. So this is just one example how 1M2M platform can support AI features. Please go to the next slide. And then that's just the beginning of 1M2M evolution for AI training data platform. But now, my thought is to evolve 1M10 platform, not just managing AI training data, but also provide a meaning to provide data quality, right? So when 1M2M is being evolved as a data platform, and then providing like AI training data and then other purposes of data, then why not 1M2M to provide how to assess the quality of data, right? Because a lot of data from smart cities and then AI services and so on will collected in 1M10 platform. Then if 1M10 platform provide the means to assess those data, then it will be very helpful for the stakeholders or service users to use 1M10, right? Depending on their need, they can choose the data. And then also those data assessment model can be applied to 1M2M. Then the quality data can be stored and then it can be used by others. So this is what I've been thinking, how 1M2M has to be evolved. So which means that 1M10 can be the data platform for AI training data and then other purpose of data. So there are different ways to assess the quality of data, like a completeness, uniqueness, accuracy, and the validity, and consistency, and the timeless, and many more factors. If those quality of data can be standardized in 1M2M, then I think it will be very helpful, and then it will be very it will provide very sustainability to 1M2M standardization. Please go to the next slide. And then, not just those new work items, but also, as I said, there are several more work items related to data. For example, data protection regulation, which means that 1M10 platform as a data platform need to consider different data protection regulation like GDPR, and then Data Act, and then AI Act, and then regulation from India and South Korea and so on. Go to the next slide.
We will get a chance to
This is
show you.
I a little bit did some mistake to place this one, but anyway, this is my kind of vision or thought to share with you that transforming 1M2M to data platform. So make 1M2M to standardize data platform for IoT, AI, and so on, and then 1M2M already support IoT data management, right? And then now standardizing the management of data for AI. That's current status. And the next step is to standardize more features to manage like a store, discover, update, etc. For AI training data. Then 1M10 can be a data platform for various emerging technologies, including AI and then whatever comes in the future. Please go to the next slide. Yeah, this should be ahead. I mean, ahead before the previous slide. So this is additional, I mean, new work item that we have been developing, data license management. So if data is available in the platform, then it also need to provide license, right? Depending on the license, the purpose of the usage of those data can be different. And then sometimes in order to train the model or in order to use in smart cities or different purposes, different license model need to be applied. And then based on those license, sometimes you can use it, sometimes you cannot use it. So those license management is also very important to 1M2M as a data platform. So we have AI enablement and then data license management and then also data regulations. Those are all data related work items that 1M2M is currently developing. And then I hope there will be more new work items in 1M2M as like release 5 or release 6 features. That's my plan and then my thought. Okay, I think that's the last slide. Yeah, that's the last one. Thank you.
Thank you, Professor Jason. I now invite Mr. Joachim Kos, founder of JK Consulting and Projects, to deliver his keynote. Mr. Joachim Kos uh, has various management positions in SW Engineering, International Project and Process Management, Conformity Testing and Approval, IPR Management and Standardization, and he's the founder of JK Consulting and Projects. Welcome, Mr. Joachim. The floor is yours.
No Q&A?
Please, sorry, this is a pre-recorded video.
Off that slide.
Jason said, ये तो pre-recorded.
I would like to send greetings from Germany to the audience. I am Joachim Kos, the founder and senior consultant of JK Consulting and Projects. As a member of the ETSI Technical Committee Smart M2M, I will give you an overview about the standardization work of this committee with a focus on semantics and ontologies. The Technical Committee M2M is developing standards which enable M2M services and applications for the Internet of Things. As a partner of the partnership project 1M2M, it supports to produce specifications which enable users to build platforms for connecting devices and services independently from the used underlying technology. TC Smart M2M evaluates virtualized IoT platforms in order to identify new elements which are necessary to support a virtualized IoT service layer. Furthermore, the committee supports the ETSI role in the standardization working group of the Alliance for IoT and Edge Computing Innovation. Here, it collaborates with the European H2020 IoT large-scale pilots and IoT platforms. The Technical Committee is the home of SAREF, the Smart Applications Reference Ontology, which enables connected devices and services to exchange information. SAREF runs with 1M2M compliant communication platforms. With it, Smart M2M is promoting the 1M2M base ontology with extensions in many IoT domains. The main focus of TC Smart M2M is interoperability. The existing literature is identifying 4 levels of interoperability: technical, syntactic, semantic, and, on the highest level, organizational interoperability. SAREF, the Smart Applications Reference Ontology, is addressing the level 3, the semantic interoperability. This means the ability of applications, devices, services, and systems to exchange data with unambiguous shared meaning and linking each data element to a controlled shared vocabulary and its associated links to an ontology. SAREF provides a suite of ontologies for currently 12 IoT domains. Each is a formal description of knowledge which shows the properties of a subject area and their relationships. The objective is to ensure a common understanding of information. Many IoT domain ontologies exist already, which are not compatible or interoperable with each other. Therefore, in the year 2013, the European Commission saw a need to abstract from specific details of individual standards. The Commission initiated a study for the creation of an abstraction layer, which is based on a commonly agreed semantics. As a result, the Commission tasked ETSI to create a reference ontology. This was the cradle of SAREF. As mentioned already, SAREF is a suite of ontologies which contain a core ontology, different extensions for currently 12 vertical IoT domains, and guidelines on how to use and extend SAREF. With that, it provides a standardized framework of ontologies which enable interoperability at the semantic level between solutions from different providers and among various activity sectors in the Internet of Things. SAREF is based on 4 fundamental principles. The reuse and alignment of concepts and relationships defined in already existing assets, in order not to reinvent the wheel. Modularity, which allows to separate and recombine different parts of the ontology depending on specific needs. Extensibility, which enables the further growing of SAREF. And last but not least, maintainability, for correcting defects, accommodate new requirements, and cope with changes. SAREF is built of a series of technical specifications, which specify the SAREF suite of ontologies. In the middle block, you can see the SAREF core specification. On top, the SAREF extensions, and below, specifications which define the developing framework and guidelines on how to use and extend SAREF. TC Smart M2M has developed 3 accompanying tools with publicly access. This serves to facilitate the SAREF suite of ontologies and to enable the SAREF community and industry stakeholders to contribute directly to the SAREF evolution. ETSI provides a public SAREF portal with user-friendly documentation of the SAREF suite of ontologies. It contains, for example, technical specifications, documentation, version control, requirements, examples, and an issue tracker. There is a SAREF Forge, the SAREF source repository for developers, and the so-called SAREF Pipeline, a support software and automated workflow for checking consistency and correctness and creating updated SAREF technical specifications to become formally standards. The technical specification TS 103673 specifies the SAREF governance process, including the development framework and different workflows which define the processes to be followed for new SAREF extensions, extension version development, and extension releases. The 3 portals, which I have introduced on the slide before, are supporting the SAREF governance process. The sustainability of SAREF is guaranteed since the development, monitoring, and maintenance of SAREF lie in ETSI hands. SAREF has a long history of about 11 years. It started with a study on agreed semantics for smart appliances, initiated by the European Commission. 2 years later, ETSI published the first version of the SAREF core ontology. Since then, SAREF has been maintaining and further developed by ETSI under stimulus and continuous support of the European Commission. Year by year, new SAREF extensions have been developed for IoT domains like energy, smart cities, automotive, and so on. In 2023 and 2024, 2 ETSI specialist task forces have harmonized and consolidated the SAREF specifications. Additionally, the SAREF European norm has been developed. During a national inquiry and weighted national vote process, all countries of the European Union and EFTA accepted this SAREF EN. With that, it will be transposed into their national norm. The high-level objective of the SAREF European norm is to give provisions how to implement, how to prove, and how to document compliance with this EN SAREF process and the SAREF specifications. The norm does not specify technical requirements or implementations, but specifies a process which refers to the SAREF technical specifications. With that, it is independent from the flexible and dynamical SAREF evolution, which is able to evolve much faster than a European norm can do. The SAREF EN contains a set of high-level outcome-focused provisions. It provides guidance on making IoT smart applications and products interoperable in compliance with the SAREF framework and technical specifications. Also, it brings together widely considered good practice in semantic interoperability for networking devices, applications, and services. With this youngest highlight of the ETSI TC Smart M2M, I would like to finish my presentation. Thank you for your attention.
Invite Mr. Myung Zeong, 1M2M SDS WG Vice Chair, KTI, to deliver his keynote. Mr. Myung Zeong is a senior researcher at the IoT Platform Research Center, Korea Electronics Technology Institute. Welcome, Mr. Seung.
Good afternoon, everyone. My name is Myung Jung, working for KERI. My presentation topic is the data standardization activities within TTA. Yeah.
Select the mic.
Okay. My name is Myung Jung, working for KERI. KERI is Korea Electronics Technology Institute, one of the sorry for the microphone. One of the active member in 1M2M regarding the standardization as well as for the promotion activity and the other stuffs. Anyways, again, so I will be speaking about the activities within TTA, and as you know, TTA is the Korean partner to the 1M2M. And this session is all about the data. And of course, as I see from the other kind of presentation, like the Jason's, there are some data standards regarding the privacy or security. My slide does not include that one, but like, let me say the pure data regarding the standardization activities. So before I jump into the activities, so let me just tell you about the TTA. TTA has three main roles. One is the standardization, like the kind of 3GPP and 1MPM, and also the domestic organizational standards, like the TTA standard itself. And there is another big pillar, which is the testing and certification. And that's why from the morning session, we say that, okay, GCF is the CA and the TTA is the active kind of test bed or test lab for the 1M2M. So they have all the kind of testing for different standards activities. And the TTA Academy, so the testing or certification and the kind of standardization, they really want to kind of promote all the activities to the kind of industries, especially in Korea, So they have the academy, so-called academy. And from KD point of view, we are throwing the 1MPM developer tutorial every year, like the basic courses and advanced courses. It's been like 4 or 5 years. So that's where we collaborate with the TTA. And this is the kind of just a partial organizational structure of the TTA in terms of the standardization. So on top, there's the technical assembly, and there are like 12 technical committees. And regarding the data standardization, I just picked the 2. And of course, the other technical committees would work regarding the data, but those 2 are the main kind of technical committees. The first one is the TC6, and in the TC6 there is PG606, which is about the metadata. So there is a really data focused project group within TTA, and the other one is under TC10, which is the kind of information technology basically. And PG101 is regarding the IoT and the smart city smart city platform, and we will see more details really soon. And under the PG101, there's the working group, so-called, which is dedicated for the data models for the smart city. And the other data-related project group is PG104, which is for the big data. And let's get into one by one. So firstly, the metadata project group. So the TOR is about the metadata and the data governance and the other data-related general stuff. So if you can see the list in the table, so there are some standards regarding the metadata itself and the data visualization, or the data access, and from the second button, which is the metadata for the My Data service. And just for your information, in Korea we have the My Data Act, which is regarding the privacy. So everyone is following the My Data Act, and nowadays you don't have to kind of install all different kind of banking apps for different banks or credit cards, companies, whatever, because with this My Data and all the standards, we just kind of can manage all different kind of banking accounts with one bank app or credit card app or whatever. Anyways, so they had the standard regarding the My Data as well, and of course they work on the data code image. And PG1001, and this is much closer to the 1M and all the smart city related kind of projects. And mainly since the TOR of this project group is regarding the platform or middleware for the IoT and the smart city. So basically, there are systems for IoT and smart cities. And for a system, there is a series for the family standards, like the requirements as part 1 and the reference architecture for part 2. And for example, like part 3 or 4 covers the data model for that dedicated system or platform. That's why you can see from the top, a part 4 data model, part 3 data model, and part 4 data model, 4 different systems in the form of IoT and smart city again. And that's one thing. So there are many kind of IoT or smart city related systems defined in this project group, and most of them define their own system data model. And PG104 for the big data, and as you can see from the list, there are some big data related kind of platforms or systems as the TTA standard, and you can find some kind of fancy keywords like the data box from third from the bottom, and the data distribution or the data. Yeah, so what they mean by the data distribution is like the kind of data brokerage, data sharing, or data kind of selling, something like that. And for the given time for myself, so this is my last slide. And from TTA, they have the other activities as well in terms of the kind of promotion or like the strategy and activity. And every year, TTA publishes some standardization roadmap and standardization and strategy map. And there are different topics, and the topics are vary every year because every year the new trends are changing a bit. And typically we have the kind of roadmap or strategy map for data. And of course we have the kind of AI topic or the other topic. But anyways, we published the kind of latest version for the data as a roadmap. And as you can see in this kind of small kind of capture, so this is the data strategy map published by the TTA. And in that kind of paper, let me say paper, there is the kind of analysis for all the SDOs, like the global SDOs, what they do, what they have been doing for the data standardization, like the IDT or GTC1 or all the SDOs regarding data. So we do the analysis and we, like the current perspective, we set up some kind of goals. Okay, these are the really good topics for the future standardization, and let's go forward. And what is the kind of strategy from the government to support us, something like that. So TTA, every year we work on this kind of roadmap or strategy map for the standardization, including data. That's it. So I think it's on time, and I will say shukriya.
Thank you, Mr. Siam. I now invite Mr. Aloknath Dey from IEEE to deliver his keynote. Mr. Aloknath Dey is the founder and CEO of the Tech Crafter CTS and former corporate vice president of Samsung Electronics and CTO of Samsung India. Welcome, Mr. Aloknath Dey. The floor is yours. Mr. Dey will be joining the conference remotely.
Thank you. And if you can present my slides.
Yes, sir. You may share your screen now.
Do you want me to share? Okay, can you see that?
Yeah, we can see your screen, sir.
Okay, thank you.
Slideshow
So
mode,
thank you.
sir.
And, again, very warm welcome to all the OneM2M community visiting India. Thanks to TSDSI for hosting and giving this opportunity. And thanks to my company, TechCrafter.cps for sponsoring the talk. So today I'm going to talk about IEEE standards for IoT and data. You have seen many different platforms and a good talk on data part, but I would be in the broad context of IoT, I will look into 8 different standards. So again, I'm an IEEE member for 30 years, 25 years with the Communication Society and working in this IoT space for very long to promote this, to build different standards. And before that, we are also working with open connectivity foundations. So first, I'll talk in 2 parts very quickly. It's 8 minutes.
Sir,
I just decided to take 8 different standards. If you can mute there. So 8 different standards we will take
slideshow
it.
mode. Sorry for interruption, sir. If you may make it on slideshow mode.
Okay. And then can you see my next slide?
Not
F5.
yet, sir.
F5. Select F5.
Yeah, please select F5 maybe on your keyboard. Oh, I don't see, sir, in slideshow mode. You may proceed, sir. You cannot delay. Thank you, sir.
Thank you. Thank you. Okay, so so I was just saying that we will do in two parts. One is 8 different standards. There are many standards of IEEE that are very close to IoT directly or indirectly. I've just picked up 8. And then last slide will talk about some of these different standards and different IoT 1M, 2M, and HC and TTA. Many people are here. So how do they relate some of these standards of IEEE? How does it fit to that? That would be of interesting. But let's just go ahead and see these standards. So first of all, IEEE P2413. This is a standard for IoT architectural framework. As you can see, it's a common reference architecture for IoT across industries. So this makes sure that there is interoperability and different verticals are also integrated. So it's a relationship standardization between sensors, networks, cloud systems, applications. And you know, it has descriptions of various IoT domains, the definitions, abstracted, and identification of components between these different IoT domains. As you can see here, smart cities, healthcare, industrial automation. So multi-domain IoT integration is the focus in this standard. The second one is IEEE 1451. This is on the very physical layer smart transducer interface standards where the sensors and then there is a processing and you have the actuators on the output side. So how do they work and provisioning a method for data sharing across this interoperability and security of messages over a network. So it can read any transducer's electronic data sheets and basically provisions for plug and play device. So this is critical for industrial IoT, smart grids, automations, effectively seamless sensor integrations. The third one, and there are many IEEE standards, you know, as you would be knowing, in 802.3, Ethernet, 11, wireless LAN, but primarily what I wanted to show here is 802.15.4. There are variations, and this is a standard for low rate wireless networks. So Zigbee, 6LoWPAN, Thread, Matters that are coming. So devices that are supporting low power and low data rate wireless communication. So this needed a specific focus, and effectively it ensures compatibility between very many short-range IoT protocols like Zigbee, Thread. We are talking 1M, 2M about broad smart cities, but we are also looking into smart homes, healthcare monitoring, some of these zonal, much more localized things with low rate. That is very, very useful. Fourth one is on P1931.1. This is where I think Jason was also presenting that how earlier AI is helping the IoT, but now IoT can bring for AI. Now, obviously, those are different data streams, but also we have software-defined networking, and that requires lots of different provisioning. So this standard is talking about a middleware layer for managing this IoT data flow and the device connectivity using SDN principles. You know, you can use today one device which can act as a cooler, but also can act as a heater, right? So how do you do that? How do you bring scalability and efficiency in large IoT data deployments? And effectively, this also helps in optimizations of data routing management. So it's meant for industrial IoT, smart grids, and large-scale sensor networks. The next one talks about standard for blockchain in IoT. I saw one part of the presentations on blockchain, and this standard effectively is bringing ensuring secure and trusted IoT data exchange. Now, in future, I think the systems would be more like zero trust. The most trusted system means actually you have to assume to be zero trust so that you manage more by the flow, the contract, rather than assuming somebody that you know of. So how do you focus on data integrity, authentication, decentralized storage that is very, very evident in blockchain, and in order to prevent IoT cyber threats? So the fundamental here is the smart contracts. You might have a health wearables data, but then you want to give it to treadmill. Maybe they will be benefiting treadmill as a device, or vice versa that you want to extract. So these would be managed through smart contracts and very, very helpful in the healthcare domain, particularly all kinds of smaller devices that are point solutions, needs data as input or wants to deliver as output, but really needs to be managed through contracts. So that's the fifth one. My sixth one is IEEE 1888. This is a standard for Green Community Control Network Protocol. We know about data management, but also energy management, particularly smart grids, but it is getting into other things. This morning, we heard about agriculture related IoT and the water management, some of these sustainable energy application, even inside smart buildings, energy management, different tariff rates. So Green Community Control Network Protocol, that's what we have defined. And how do you do efficient data exchange between IoT devices, keeping in mind that you want to monitor energy, you want to care for environments, and you want to minimize or even benefit from the tariff routing. The seventh one, this is quite unique, and we have many data, and we've been talking about big data, right, in the previous one. And question is, how do you access, how do you manage, how do you give it? But what's the trustworthiness of data? Because data, same data may be coming from multiple sources, and we might be confused. Effectively, you need to define a trust index. So this IEEE standards is defining IoT trust index, and I think it's even ITU-TI, it's named, to be able to assess the data reliability and security in the systems. So we want to make sure that data from IoT devices, whatever we are using, is trustworthy, not fake, reliable, cross-verified. There are systems for that, and particularly where there are critical infrastructure, either in healthcare or in the grids or in autonomous system, this would be even more valuable than maybe lesser critical systems. The last one I wanted to highlight is standard for edge computing. We talk about cyber physical system device and the cloud, but day by day we see fog or edge computing is becoming important. Even this present LLM, this big breakthrough that has happened through DeepSeek is effectively, it's an edge computing would be much more beneficial. Instead of doing big LLM in the cloud, this has given a chance for us to bring AI algorithm closer to data and do edge computing. So this standard is evolving into that direction. It's not yet to take care of the recent development, but there are architectural guidelines and best practices for edge computing, for real-time data processing, latency sensitive applications. As we know, as we progress towards 6G, there are machine-to-machine communications, two kinds of things. One, we see massive machine communications where it might be non-critical, but the numbers are important. Whereas there are systems which will have critical systems, you need robust data and could be latency sensitive. So how do you do that? Through the edge computing. So I think that was the first part to introduce 8 standards. There are many more. I have a list of 2025. We don't have time for that. But I wanted to highlight and conclude with this last slide, which would be interesting for all of you. How does this fit IEEE standards and all of the things? And I must say that in November 2024, there was in the World IT Forum in Canada, there was a forum and a roundtable on these data standards landscape. and all of you from 1M2M and ETSI, they participated. So 2413, that is IoT architecture, this aligns with 1M2M and ETSI Smart M2M for structured IoT framework. We talked about wireless networks 802.15.4 and 111 smart grids. That's related to smart M2M and IoT SD20. 1451 sensor interoperability, that ST's ISG SIM and the TTA for harmonized device communication. That is very, very relevant. It supports that. P1931.1 IoT middleware and the SDN aligns 1M2M's common service layer for data management. 2510 edge computing goes with ETSI, ISD SIM and ITU-T SD20 for real-time processing. The blockchain security 2418.1 integrates well with TTA and 1M2M for trusted IoT transactions. And IEEE 2668 data trustworthiness could be very, very relevant with the smart M2M and SD20 to be able to ensure reliable IoT data. So I think that's kind of thought process, but there are newer things that are evolving in terms of digital twin, in terms of semantic communications and ontologies. I'm sure we can continue to work together. So with that, I pause here. These are my details. You can take a snap. If you would like to communicate either through LinkedIn or email, the details are here. Thank you. Over to you.
Thank you, Mr. Dev. Now, there's a time for a 5-minute Q&A session. The online folks can put their questions in the Q&A tab.
There are few questions in the question tab. I think earlier session, for the earlier session, I think only one question from the audience. Is there a gray area at challenges in implementing standards for drug control? So that is the question, I think, for 12 room session.
Can I ask one question? Yeah, thank you. So basically, it is question to everybody. I see a lot of ITU standard, IEEE standard, 1M2M standard, all these things. If I'm a layman, which standard should I follow, and what is the route I should take?
Yeah, thank you, ma'am.
I can take, I'm already anchored. This is Alok here. And that's exactly was the reason why I showed the previous slide, which says, so I would say that whichever body that you like or you are participating, let's say you are into 1M2M or in the IEEE or in ETSI, anchor there first and see what do they have. And I think just the previous slide, if somebody can click, then you can see, based on that, if I am in the IEEE, I know what we have built and I know who exactly are working in these. So item by item, I will go there and be able to see if it is complementary or if it is overlapping. If it's overlapping, two bodies should be working directly onto that point. For example, if I say blockchain or IoT data trustworthiness, we know exactly who else is working. It is an important topic, and you see if it's complementary or overlapping from that. That will be my answer.
Yeah, okay, thank you. This is Soren Tekvatten from 1M2M. So I very much agree with what you said. It depends. I think what is also required to distinguish what is a standard supposed to solve? There are different levels. So either it's a protocol or it's a more, I think, talking about one of them, it's more as a service enabled that reuses existing protocols, using existing concepts, even interworking with existing technologies. So I think it's a little bit different level. So the problem is if you list it as we can do, then it's hard to distinguish. It's always important to see what does the standard want to solve. So you can and whether it's a very concrete thing like a protocol, you can use each and every protocol, for example, in a one-time implementation. But we don't have own protocols in that way. So this is one of the differentiations. Then the next one is on the deployment, whether or not it's deployed with in architecture where you have edge infrastructure devices and devices, it's manageable with one of them. Whether it's so-called near real-time or real-time, it depends on the protocols underneath and on the connectivity network much more than on for example, a standard like OneWeb. So it's a relevant question, and I think to answer it, you always need to know what you want to solve and which standard describes what. So we learned about standards that's describing processes. So these might be guidelines to see what needs to be done and which standards would help in which process step. So I think it's not that easy but yeah, but one has always be careful not to mix up different levels of standards, I would say, or layers. It always depends. But yeah,
Yeah, I totally agree. 1M, 2M may not be directly related to I2U standards, whatever process they are defining. But I see there is a lot of redundancy when you see ITU standard, IEEE standards, the same statement, different numbers.
Yeah.
And as I said earlier, if I was a layman, I don't get a chance to read, go through it and decide which standard to follow. I would like to have you follow this standard, right? That would be a better proposition for a layman. If we are technical, totally agreed. Like I'll go through it and see which applies what. But yeah, thank you.
Yeah. Sorry.
For simple reason, I think I can say that we can adopt the national standard, whatever DEC has adopted. 1M, 2M standard has been adopted as national standard. So we can follow that in the absence of any specific requirement.
Thank you.
Thank you.
Okay, with that we conclude session 3. Thank you all to all our esteemed speakers for sharing their valuable insights on the evolving global standards ecosystem. We now move forward to the next session, that is awareness session